Okay. Now let's talk next about the slicing software. So you've got this 3D object file that you've downloaded from the internet. So now how do you take that object from virtual reality to actual reality and print it up? Well, you need to slice it. So you need some slicing software. Now, before we get into the slicing software, let's talk about a few design considerations. Okay, so what you need to think of when you are slicing your object is the orientation of that model on the print bed, whether you have overhangs that need support, your temperature for print bed adhesion, and making sure that that nozzle is calibrated down to your printer really, really precisely so that it lays down first layers really well. You got to think about your resolution. That's the thickness and thinness of your lines. Like I said, thicker layers mean less time, but it also means less detail. Thinner layers means more detail, but longer print times. You need to think about your infill. That's your interior support, how much interior support that object needs. You need to think about your print speed and your temperature. So certain filaments print at different speeds and at different temperatures. And if you see like your print getting really stringy, you know that that temperature is probably a little too high or the speed is a little too fast. You also need to think about your calibration, how you have your printer calibrated so that that nozzle is right next to the print bed when you're printing. Now, these can be overwhelming. And I know that I just hit you with a bunch of stuff here, but do understand that each one of these links on slide 31 will take you to a dedicated page about that design consideration, about that design element of a print. And what's so awesome about this slicing software is that there are default settings for everything. So when you first start 3D printing, and you open an object in your slicing software, there are default settings. So you can just go with the default settings for PLA filament and then start your printing process. And then as you get the hang of things, you can start to make little tweaks to improve the quality of your prints. So print with the default settings at first, learn the process, and then you can start making little tweaks like, oh my gosh, I noticed some stringing happening on that print. So I'm going to dial down the temperature just a little bit. If I'm seeing visible layers in the print, or maybe a shift in the layers, maybe it's not adhering down quite as strongly that I need to. And so I have to move my nozzle down for the calibration. So again, you've got default settings, use those default settings. Okay, now let me buzz through the software here. So these are all links. So kind of the go-to slicing software, the granddaddy of them all is Cura. Cura has been around for a long time. It is open source. It is a great slicer and very simple to use. Prusa Slicer, to be honest, is my favorite one. I think it's more feature rich and easier to use than Cura, but it is also open source. So again, you can download these software packages by just clicking on these links, and they will take you to the software. So Cura is good. Prusa Slicer is good. Simplify 3D is really good, but again, that one is subscription based, and there is not a free version of that one. It is $150 for 2 subscriptions. And then there's Slicer, and Slicer is an old G-code generator that the Prusa Slicer is built on, and it is an older version of Slicer. It's definitely more code based. It's definitely more text based. So not quite as visual. So again, has options that you don't see on other slicers, but it is definitely more tricky to use because it's not quite as a visual. It's much more code based. All right, now let's buzz through these last couple of options here. So creating a 3D printing workspace. So basically, kind of the rule of thumb when it comes to 3D printing is when you create the space, there are 3 schools of thought on how to create your layout. You have got the makerspace setup, which is where your printers are out amongst your students, scattered around the room. You have the general printing area set up where you have maybe a table set up at the back of your room where students can print. Or you have an instructor's printer if you maybe just only have one printer and you're using it for demo. So you really need to just determine your needs and figure which setup is best for you. As a former biology teacher, I would probably use the general printing area setup in my classroom. Now, a few things about printer placement, whether you're going to put that in a classroom or whether you're going to put that in a communal space, and some things to think about there. Also some do's and don'ts, and this revolves a lot around filament. Filament is what we call hygroscopic. It absorbs moisture from the air. So you need to store your filament in airtight containers that have some large desiccates in them to keep moisture from building up. We live here in Illinois where there's lots and lots of humidity during the summertime. So definitely store your filament in when you're long-term storing your filament, put it in some airtight bins and put some great big desiccates in there to absorb that moisture. There are also filament dryers that you can buy, or you can convert a food dehydrator into a filament dryer. Now, I also have some recommendations for some tools. Obviously, there are going to be some tools that you need here. So on slides 41, 42, and 43, I've listed out the common tools that you're going to need when 3D printing or demonstrating in class. So take a look at those. Or you can buy a 3D printing tool kit, and there's lots of great ones that are available. This Matter Hackers one is awesome and available on websites like Amazon and things like that.